Okay, we're going to do 2b. It already messed us up. 2b. So we talked about 2a, which was horizontal asymptotes. So now we're going to talk about vertical asymptotes, okay? Vertical. It's not that bad. Mr. Parsons said I have to email the the app maker and let them know I'm having difficulties with it. So the more people that tell them, then they'll do something about it. Oh, that's good. Okay, vertical asymptotes. Let's start with how to find a vertical asymptote here. It says that if the limit as x goes to a constant a from the right of f of x is plus or minus infinity. So as we're going towards a from the right, if we get a limit of positive or negative infinity, or if the limit as x goes to a from the left of f of x is plus or minus infinity. So either or both, it doesn't matter, but at least one of them has to happen. Then x equals a is a vertical asymptote. Okay? All right, so let's do some. Are you ready? Now, you can use your calculators on these. I know I don't really like to, but that's okay. So number one, you don't really have to, though, a lot of times, though. Like, you can see these by looking at them. We're just going to practice finding the vertical asymptotes of things. Find the vertical asymptotes of, and let's do a couple of these just to remember how to find a vertical asymptote, things like that you did in ham or RAM. So let's say that f of x is equal to 1 over x plus 3. Now, the way that you find a vertical asymptote is it's going to be the zeros of the denominator, okay? Not all the time, though, and we'll talk about that in just a minute. In this case, it's true. So the domain of this function is all real numbers except for what? Negative 3. Can't have negative 3. That's a no-no. Plug in negative 3, you get 1 over 0. So there is a vertical asymptote at x equals negative 3. Okay, letter B. G of x is equal to 5x plus 1 over x squared minus 4. Okay, yesterday we focused on the horizontal asymptotes. Today we're doing vertical asymptotes. So what would the vertical asymptotes of this one be? Yeah, you could factor it if you need to, or just realize the zeros of the denominator would be x is equal to plus or minus 2. This one has two vertical asymptotes. One through x equals 2, the other one through x equals negative 2. Okay, how about this one? H of x is equal to x squared minus 25 over x plus 5. Now here's the one that you have to be careful about, okay? You cannot just simply write x equals negative 5 is your vertical asymptote, because that would not be true. This right here, you can factor the numerator as x plus 5 and x minus 5, and the denominator has an x plus 5. So what happens is you can remove this. And so it actually has a removable, it's a hole in the graph. Yes. This actually is the graph of a line. It's the graph of h of x equals x minus 5 with a hole in the graph. It doesn't even look like the rest of them. Like, you know how you graph these rational functions and they all pretty much look like that and that, you know? This one right here would be a line with a hole at -5. Okay? So this one, vertical asymptote, none. No vertical asymptote at all. Okay. Now, that was just warming up, finding asymptotes. Now we're going to find limits, because limits are very much linked to these asymptotes. So, for example, we're going to find the limits, and you're allowed to graph these on your calculator. We'll try and do most of them without, though, because a lot of times when you get to college, your professor, that looks really bad, your professor won't let you use your graphing calculator. Yeah, you do a lot of this by hand. Okay, so here we go. Let's do find the limit. The limit of 2 over x plus 3 as x goes to 3 from the right. From the right. Okay, so, yeah, you can't do it that way though. Oh, I'm sorry, -3. You're right. You could just plug in 3 and it would be it. I'm sorry, -3. -3 from the right, because that's where the asymptote is, right? So if you graph this, 2 divided by, I'll show you on my calculator, 2 divided by x plus 3, zoom 6. If you graph this, it's your basic rational function. You know, at -3, there's a vertical asymptote. And so it looks like that and that. So as we're going towards -3 from the right, our graph is going up towards what? Infinity. So the answer would be infinity. Okay? There's a horizontal or vertical asymptote there, so it goes to infinity. Now, what would be the answer? The limit as x goes to -3 from the left for the same function. I'll call it f of x. Yes, perfect. So you jump on your graph, and you're going this way from the left towards -3, and our graph is going down to -infinity. Okay, let's try another one. Letter C. Let's do the limit as x goes to 2 from the right, 2 plus, for 5x plus 1 over x squared minus 4. Okay, we know that at 2 and -2 there are vertical asymptotes. So this is going to go to either infinity or -infinity. Remember when we did continuity last year? We did infinite continuity, we did removable discontinuity. This is an infinite discontinuity because the graph is discontinuous at these points 2 and -2, and it goes off to infinity. All right, so let's go ahead and graph it. So this one's going to have 2 asymptotes, so let's see what that looks like. Parentheses 5x plus 1 divided by parentheses x squared minus 4. X squared minus 4. Okay, I don't really care what's going on at all these points, so I know there's an asymptote at -2 and +2. In the middle, it looks like a cubic function, and on the side, it looks like that. I really just care about what's going on as x approaches 2, +2, from the right. So let's go to, here's +2, and here's the right of it. And as I'm going towards 2 from the right, my graph is going up to infinity. And you figured that out. Okay. All right, so that's vertical asymptotes, finding the limits, stuff like that. You're able to graph, don't worry about that. And now let's do part B. Part B is all about the end behavior. End behavior is a really complicated thing when you make it complicated, but it can also be super easy if you just do a little trick. Okay? What's that?
Is the answer like positive?
No, the answer is going to be like, say you have a graph. We want to know what's happening at the left and right of it, like way out there. It's just going to be like the first thing. Yeah, we'll do it. Okay. You're like, yeah. Number 3. All right, it says f of x is equal to 3x to the fourth minus 2x cubed plus 6. Now, back in advanced math, we learned something called the leading term test. The leading term is the term that has the greatest exponent, okay, in a polynomial like that. And this really determines what the rest of the graph is going to look like. This is where we decided if it was down, down, up, up, or falls to the left, falls to the right. Remember, there was like this chart that we made? I don't remember that. Okay, so end behavior, basically if it's a polynomial, it's going to have an end behavior of whatever the first term is if it's in standard form, okay? So they want you to write a simplified function for the end behavior. We'll call it g of x, and our simplified function would just be g of x equals 3x to the fourth, okay? If you were to graph both of these, this would be y1, this would be y2, and you went as far as you can out to the left or right, they're going to be pretty much the same graph. They don't do the same thing in the middle, but end behavior means that way, left or right, okay? So it's like this. You could have, you know, a fourth degree polynomial doing that, and then your regular fourth degree polynomial or simplified one goes like that, but here and here, they're doing the exact same thing. That's all they want. Okay? All right, number 4. What happens if it's not a polynomial? So let's do this. F of x equals 5x cubed plus 3x squared plus x over x minus 3. Okay, what is going on with the end behavior on this? Well, what you're going to do is you're going to look at the leading coefficient or the leading term of your top polynomial and the leading term of your bottom polynomial. And you basically create a new function of the two of those. So it's 5x cubed over x, which reduces to 5x squared. So basically what this is saying is this rational function that's a pretty big, decent sized graph is going to act like a parabola at the far end and at the far ends of it.
So we don't have to describe going up and go left and down.
You have to just write the simplified
Wait,
function of it.
Last year we wrote like up, right?
Yeah, not for rational functions we didn't. We did for polynomials. No, they want you to find a power function and behavior model. They want you to have a model for it.
So you don't have to write
Nope, you don't have to write up, or up, down, or anything like that. Nope, that was it.
ever.
What's the horizontal asymptote here? It's a trick question. There is none. Okay, there's no horizontal asymptote here, right? The degree of the numerator is bigger than the denominator. And if you look at a parabola, is there an asymptote for a parabola? No, it just keeps going up to infinity. Okay. All right, number 5. Let's try 4 more. Let's do f of x equals 3x squared plus 6 over 2x squared plus 1. Yes. So our end behavior model would just be 3 over 2. And that should make sense to you because we learned asymptotes yesterday. What's the asymptote of this? Y equals 3 halves. So when we take our graph and we go as far left or as far right as we want to go, it's going to act like this because it's going to go right along that asymptote, right? If I were to graph 3 halves, here's horizontal 3 halves, and my graph went like that and it went like this, okay? Well, at the very outside parts of it, my graph is acting like y equals 3 halves, way to the left and way to the right. All right, one more. Number 6, last one of the day. F of x is equal to 5x plus 2 over where is it? Negative x squared plus 3x minus 1. Okay? So I need to find the end behavior model, and then I'm going to find the asymptote, the horizontal asymptote of this. All right, so my end behavior model is to take the leading term of the numerator over the leading term of the denominator. And so we get g of x equals 5x over negative x squared, which is equal to negative 5 over x. So that's what it's acting like on the outskirts of this function. It's acting like negative 5 over x. And what is the horizontal asymptote for negative 5 over x? Plug an infinity into that. Plug a negative infinity into that. It's going to go to 0. You get bigger and bigger numbers on the bottom, it's going to lead you to 0. No matter if it's from the left or from the right, it's still 0. Okay.